this to take the CO2 or other greenhouse gases from the atmosphere and lock it somewhere else out of the atmospheric system. And what we're going to discuss today is BECCS. So this is one of them. It's called Bioenergy with carbon capture and storage. So the whole point of this method is to remove carbon from the atmosphere using the biomass, which is also a source of energy. So in a simplified way, the carbon cycle of BECCS method is that first you have CO2 in the atmosphere. It's absorbed by plants, basically, by photosynthesis. And then plants are used in various ways, various processes like combustion, fermentation, aerobic or anaerobic digestion, gasification. And so from this, we get some form of energy. And the idea is to capture the CO2 out of these plants and then to put them in a form of geologic storage, for example, or other types of permanent storage in order to get the CO2 in a permanent way outside of the atmospheric system. And of course, with BECCS, you get on top of it some energy products, which are the result of the process that is implemented using the biomass. So that's a simplified carbon cycle way. So, and at the end of the result of the process is that CO2 starts here and ends up, part of it, in a geologic storage formation. So it's out of the atmospheric system, and we have reached our goal with that. So this is a multi-part process, and it's complex. So with our panel today, we'll try to shed lights on the different steps of the BECCS, let's say, value chain. Okay, so this is. I'm happy to introduce our panelists today that will each, in their specialty, tell you about one aspect of the project. So initially, we had a guest from Bioenergy Europe, Ennio Prizzi. Unfortunately, I have to apologize on his behalf. He couldn't make it. He caught a flu yesterday, so he had to cancel his trip at the last moment. But we'll have Erika, LAAJALAHTI, I hope I didn't butcher your name, who will step in. She's working in Bioenergy, the Finnish Bioenergy Association, and she will actually introduce the panel with a presentation on the regulatory and policy environment for CDR in general, both at the EU level, but also illustrating the case of Finland, which is one of the, let's say, fastest progressing and most progressive countries in Europe on carbon removal. So with that, we'll cover the policy part of this BECCS value chain. Then we'll have Mohamed MAGDELDIN from SUMITOMO, SHI, FW, for WastetoValue, I guess, yeah. So Mohamed will talk to us about progress and updates on the technology side for the capture of CO2 from different technology perspectives, and you'll have the latest on the first step of the physical process for the BECCS, which is capturing CO2 from typically a flue gas. We'll have Aymeric stepping in just afterwards. Aymeric, yeah, sorry for the typo, from Airfix. So Airfix is a developer of transport and sequestration solutions for bikers, and which is another acronym for BECCS projects. Airfix is a subsidiary of the carbon credit developer South Pole, and Aymeric will show experience on existing projects in Europe today about BECCS, how they work, focusing on the biogas supply chain. And he will also explain the challenges faced with the transport phase of the BECCS ecosystem. And at the end, I'm happy to introduce Patrick Portolano from EOSYS. So Patrick is a specialist in geology. He has a background in the mining and geologic activities for large companies, and he has founded an advisory firm which is specializing in the geology of sequestration. So he will, at the end of the session, give us some insights about how to store safely CO2 for a long time in the atmosphere. So I hope with that you'll end up with a good view on what's happening in the CDR and BECCS world at the end of the session. And I'm happy to introduce Erika as the next speaker to tell us about policy of CDR. Erika, please.
All right. Hi, everyone. Great to be here. My name is Erika LAAJALAHTI, which, by the way, means Wide Bay in Finnish. Quite a long name, even in Finnish standards. So I'm here to tell you a little bit about the policy. Like Karim told, originally I was supposed to concentrate more on the Finnish context. But now that Ennio is not here, I promise that I can cover the EU side of it at least in some detail. And then tell you a little bit of what's going on in Finland and what we think should happen in Finland and in EU in order for us to scale up BECCS deployment. Okay. It's not working? Yep. Okay. No. Okay, here we go. So to start, just a few words of where I'm coming from. So the Bioenergy Association of Finland. We are a business association representing bioenergy sector, but also forestry, landowners, energy companies, as well as technology in the field. And to put it short, what we do and what is our main goal, we want Finland to be the best place in the world to create bio-based, sustainable, and even carbon-negative solutions. So that's what we're working on. And in this work, we have a couple of parts in our organization that are extremely important, and they are carbon removal and CCUS committee that has 16 organizations that I'm running. I'm running the committee. And we have a separate biochar network, since biochar is also really moving on fast in Finland. But moving on to the actual subject of the day, Karim already touched upon this global setting the scene in a way, so I will not go into the details of this anymore. However, I would like to point out that so we need negative emissions. That's just a fact. And then there's also another fact that is true in this field, is that the more we delay emissions reductions globally, the more we are going to be needing carbon removals. So that is something that we should keep in mind while moving forward. Going a bit closer to the EU side, so from the global context. So here we see sort of what we are planning to do in the EU, or what we are aiming to do at least, because we have legislation in place that should take us to climate neutrality by 2050. So we have the 2030 target, minus 55 emissions reductions, and then we have LULUCF targets for the sinks. But in order for us to get to the climate neutrality, it is clear that we need to put our efforts into scaling up carbon removals, and especially permanent carbon removals, in order for us to get there. And EU has done quite a lot of work regarding CDR lately, or in the recent years. And as mentioned, the climate law and the target of climate neutrality and net removal thereafter, of course, is the wider sort of umbrella under which all of these other policy elements are going to be placed. But here, I would just like to mention, and I added a little comment on this Ennio's slide. It's that the Commission is currently preparing the 2040 target, and they will announce the communication in the beginning of February. But the Commission has already said that within the 2040 target scenarios, there is not a single scenario that does not include scaling up CCUS technologies and fast. So it is going to be a clear, big part of the EU's climate policy in the coming years. So as I mentioned, we already have regulation regarding carbon removals in the land use sector. But this is not enough, and what we know by now is that we have some significant problems in reaching these targets. Several countries have issues with their LULUCF sinks and also emissions in the land use sector. So this is a clear driver for their technological solutions, since we cannot rely solely on the land-based removals. Well, the Commission started the work regarding the technological solutions in a more concrete way in 2021 with the Sustainable Carbon Cycles communication, where they for the first time talked about the industrial solutions that can help us removing carbon dioxide from the atmosphere. And they outlined this not binding target, but aspirational goal, so to say, of 5 million tons of permanent carbon removals with technologies by 2030. And some people have commented on that this is maybe not enough and that we should do more. But this was a good start in order for the industry to understand that, okay, this is something that we need to be working on, and we need to put our work in to get to those levels and beyond. Then we have other legislation that has been put in to the table after sustainable carbon cycles. So one key element that the Commission has been working on is the carbon removal certification framework. So just to say that, okay, we have these solutions that can help us in reaching the carbon removal targets and making rules. Okay, we have these solutions, for example, BECCS. How should those projects be looking like, and what kind of standards should be utilized in these projects? So this is sort of the main goal. However, there is no clear mention of why this certification framework is going to be in place. So are we going to be using it for what reason? Is it for the voluntary market? Is it for compliance market? What's going to happen next? So this is not clear yet. Then on the other hand, we have the Net Zero Industry Act that was introduced in March 2023. And in this one, the Commission has clearly focused on the storage side. So a clear bottleneck for these projects is that, okay, we need to capture the CO2. In case of BECCS, we need to capture the biogenic CO2. But then that's not enough. We need to put it somewhere where it stays for a very, very long time, so thousands of years. So in the Net Zero Industry Act, the Commission outlined a target of 50 million tons of storage capacity by 2030 in the EU area, so not including Norway, not including UK, for example. So that was a good signal because this is clearly a big part of the project that needs to be in place in order for us to move on with the projects. And then, of course, last but not least, we have the industrial carbon management strategy that the Commission is currently working on, that they will publish a communication regarding that together with the 2040 climate target on the 6th of February. So in that one, the Commission is looking into more detail in the CCUS technologies. What do we need, or what kind of solutions do we need to have in place in order for us to scale up carbon management? So carbon capture, utilization, or storage projects in the EU level. And infrastructure and storage potential will be the key elements in this paper. So moving on, these are, as you see, Bioenergy Europe's slides, so Ennio slides. But we fully agree with these statements that what we need for BECCS to flourish in the EU is that we need to have a clear picture of the amount of negative emissions that we are going to be needing. And together with that, we need to set clear targets for those solutions. And it is clear also that we need stronger policy support and market incentives for the development and especially for the deployment of BECCS. So this is not currently happening besides the voluntary market. And of course, if we are putting all our eggs in the technology basket, then we definitely need to put a lot of efforts in the R&D as well in order for us to actually get to the large-scale projects in reality and to show that, okay, these projects actually can deliver these negative emissions that we are desperately needing. And as I mentioned, we do have the land-based removals and the targets regarding those ones. We might need to separate the targets for the removals since one single target might not push the technological solutions the best way forward. And of course, these solutions do have different aspects regarding permanence, for example. And what is key in this emerging industry is, of course, collaboration, not just between governments, but also we're talking about industry players, research institutions, civil society organizations. We need to engage everybody in the discussions and speed up the process of deployment this way. Okay, so I don't know how much time do I have, but I'm speeding up, going into the Finnish Finnish scene. So as Karim mentioned, we do have quite high climate policy targets in Finland. So we are aiming to be climate neutral by 2035. So in 11 years. So that's a big target. And we also have additional emissions reductions targets for all the way to 2050. And within this climate neutrality target, we do not have a specific LULUCF target, but we do have a strong assumption of having a strong LULUCF sink. And we do not have targets for technological sinks at the moment. This doesn't mean that the technological sinks could not feed into this target, but this is the situation right now. But we have been doing really great with the emissions reduction side, and now we do need to put efforts in the sink side in order to get to our goals. I will not go into the details of all of this, but I will just say a few words from this slide. And one thing is that we have a Finnish climate change panel, like the EU has its own, and then we have the IPCC. So our climate change panel has said that our government, that we currently do not have a strategy for negative emissions, but they have said that we should have a strategy and we should have 5 to 6 million tons of negative emissions produced with the technology solutions in order for us to reach the 2035 target. So if we would like to get to these numbers, that means that we have to start working today. And we have a lot of work to do. We are very excited about hydrogen in Finland. I will not go into the details of that, but that is just something that is good to understand in the CCUS conversation. We are putting a lot of effort in the hydrogen economy pathway as well, and carbon capture is, of course, an evident part of that as well. I guess the biggest new step in the policy context of Finland happened in June last year with the new government program, and it's outlining regarding carbon capture. So it was a clear new strategic move from the government, and they put the CCUS solutions as one of the key priorities of Finnish climate policy. And this is very new. And the government has also outlined a lot of smaller targets, but I would say that the biggest target that was incorporated in this program is that Finland, or our government at least, wants that we do not put any carbon dioxide emissions into the atmosphere from large industrial sources by 2035. So no emissions to the atmosphere. Means huge, huge carbon capture, utilization and storage potential in Finland. One thing that is a bit of a, let's say maybe not, it's not going to stop us from doing this, but it's a clear piece of this puzzle that is slowing us down, is that we do not have as big pockets as some of the EU countries, such as Sweden or Denmark, that have put very significant amounts of state money into the developing of the projects. In Finland, we do not have that much money put inside for these projects. We have some, but this is not going to be enough, for example, to create this sort of reverse auction for negative emissions that, for example, Sweden is planning. So we are going to be needing private money also in order for us to reach the targets. And here's just a quick picture of the point sources of CO2 in Finland, the largest ones. And to point out the potential for BECCS, it's quite, I would say, huge if we compare to many other EU countries, for example. We have about 28 million tons of biogenic CO2 produced annually. Forest industry and energy industry and waste energy plants. So it's clear that this is huge potential. We have about half of the point sources in the coast, so interesting places maybe if you're planning storage projects. And we do have some issues with renewable power and versus CO2 point sources in certain parts of Finland. But I think one key thing to understand from the Finnish context is that we do not have geological storage sites identified. So if we want to move on with the BECCS project, we are going to be needing international partners. And that is something that I hope that we are working on fast in the coming months and years. So as I mentioned, hydrogen is very big interest in the Finnish context. There's a lot of ongoing research regarding power-to-X, biogenic CO2 value chains, mostly regarding products. Then also some research regarding storage in minerals or in products such as concrete. But most of our projects are concentrated in the utilization pathway, and most of them are producing synthetic methane for heavy transportation. But just to say, point out this thing is, it's something that I always say in the Finnish, when I have a Finnish audience, is that we have calculated that the projects that we currently have announced, they would need roughly about 1 million ton, 1.1 million ton of biogenic CO2 annually. And we have the 28 million tons. So we do have a lot of potential. So it's not either or, we can do both, and we should do both. And according to our industry that we are, of course, engaging very closely in the discussions, it is still technically possible and to have BECCS projects ongoing before 2030. But in this access to storage side is a clear bottleneck that needs to be addressed fast. And here's just a sample of the CCU projects, just to show on the list that we have a lot of them ongoing in various stages, but this is a clear interest in Finland. Okay, so I'm going to be finishing soon, so don't worry. There's still some clarity needed if we want to proceed with CCS, like I have mentioned earlier. The first and foremost thing is to have the clear strategy, not just on a national level, but also in the EU level. And this strategy should include targets and also address, for example, public acceptance, or not just maybe acceptance, but mostly understanding. Then, of course, financing model is very important. The EU legislation currently does not reward from the capture and storage of biogenic CO2. Instead, it rewards from the capture of fossil CO2. So we are very much looking forward to the ETS review in 2026 that will look into possibly including negative emissions in the EU ETS in one form or another. And then, of course, we have the carbon removal framework coming on sooner or later. But then, in order to get the private sector also into the picture, we need more clarity in the targets that we have on government level, on company level, and the claims that we use in these targets. And the double claiming discussion that is ongoing in this segment should not create an obstacle in order for private sector to finance projects. So this needs to be resolved. And of course, the voluntary carbon market, I have one slide, next slide on that still, so let's get back to that quickly. But as I mentioned, if we want to build the CCS chain from these point sources to the storage, we need planning, investment, permitting on the Finnish ground, but also the collaboration with storage countries. For example, these bilateral agreements are a necessity to move forward in the actual projects. So a lot of work still to be done. I will not go into the details of this slide, but just to slightly touch upon the financial aspects of this theme, and like I mentioned, this voluntary market for CDR, so permanent carbon removals, not so much the earlier years voluntary carbon market that was mostly based on land use sectors projects or emissions reduction projects, but this sort of a new up-and-coming market for the permanent carbon removals is going to be the clear driver of demand for these projects up until the 2030s, after which the compliance markets, for example, in the EU might take a bigger role. But as we know, the legislation process takes a lot of time, so we don't believe that we have a EU-wide system in place fast enough. So we need to put the private money to these projects. We need, of course, public funding as well, but it's not enough. We need to go to the gigaton scales in the CDR globally. So in that, we are going to be needing public financing, private financing, and combining these two. So this is something that needs to be possible for if we want to have carbon removal large-scale projects in the coming years, way before 2035. And in summary, like I guess I have already mentioned, I think we have huge potential in Finland for both BECCS and also BioCCU. And we will become a massive force in providing emissions reduction solutions as well as negative emissions. And even though you can see that the political support has grown significantly, the financial side for large-scale projects seems unlikely to reach the level that it should. So decisive role for the voluntary market is clearly there. So infrastructure is something that I haven't talked about a lot, but it's something that both of these pathways are going to be needing. And they will need it in national level and at the EU level. And as the EU is now currently planning the EU-wide CO2 infrastructure, I think it is essential that that kind of infrastructure addresses not only the needs of fossil CO2, but also the needs of biogenic CO2 solutions. And as I mentioned, private sector's credible financing and the access to storage sites are clear key elements if we want to have these projects in place in the due time. But here, I'm finished. Sorry for if I took a too long time, but
No,
thank you.
perfect.
Thank you for your attention.
Aymeric Raymond, who will give us some return of experience in Europe and a focus on CO2 transport for BECCS.
All right, good morning, everybody. Very nice to be here. So my name is Aymeric Raymond. I'm part of Airfix. We work on biomethane CCS and in general BECCS. Maybe just a couple of words about Airfix. So we support biogenic CO2 emitters in developing their BECCS projects. So helping them to find a capture provider, so technology provider, helping them to find the transport services, storage services, and then the whole MRV process and sales of the final carbon removal certificate. So we really try to be a one-stop shop basically for emitters to help them to develop their projects. We also help through advisory services for emitters that are at an earlier stage of their journey to help them understand how the value chain works, whether their project is eligible or not, and trying to basically motivate them and show them that it is possible to do this now and we don't have to wait till 2040, 2050. And the last piece of what we do is advocacy. BECCS is still at a very early stage, so in most countries where we operate, there are still quite a lot of regulations that need to change or, as Erika mentioned before, bilateral agreements between countries that are needed to authorize the CO2 to be transported from one country to the other for storage. So in general, we are based in Zurich in Switzerland, and we operate in the European market, so we're working on projects in Switzerland, France, UK, Germany, and open to others as well. So my main focus today will be to talk about one specific project in Switzerland, which is our sort of first flagship project. It's the largest biogas project in Switzerland, but Switzerland is tiny, so the project is still relatively small. It's 5,000 tons of CO2 per year. But it's a biogas plant that will be built in the next year. The construction permit is currently under approval, and it's a biogas plant that is developed by Regionalwerke Baden, which is a small town close to Zurich, which actually already operates this CCU plant in an existing biogas plant that they have. So they have experience with carbon capture. Right now, the CO2 that comes out of this plant is delivered to the food and beverage industry, but they also see that the demand for CO2 in Switzerland is quite limited. The annual demand is around 100,000 tons. So very quickly, the CCU option in Switzerland will be saturated, and they will need to look for other options of what to do with their CO2. So with this project, they want to set the first foot onto the path of carbon capture and storage. So as you might know, there is no storage yet in Switzerland and none for the foreseeable future, sadly. So we have to transport the CO2 to the current storage sites that are available, most of which are in the North Sea. The way to do this is through a combination of modalities, so trucks for the first mile to reach the closest train station, because the biogas plant is not linked to the rail directly. Rail to then go from Switzerland all the way to the North Sea, and typically the final last mile sometimes needs also truck, but also potentially a barge to bring the CO2 to the injection site. The storage is still to be determined, so we are in discussions with several storage providers in the North Sea, in Norway and Denmark, and they're looking for the best solution for the project. And the CO2 would be stored in depleted oil and gas fields or saline aquifers. And the good news is that we already secured a buyer for the carbon removal resulting from this project for the first 5 years. from the Swiss Climate Sen Foundation. So they will take all the carbon removal certificates that are generated by the project between 2026 and 2030. So what I wanted to share with you a bit today is what have we learned from the past 1.5 years, 2 years working on this project. To be quite transparent on the challenges that we face with these projects, but also the opportunities, and try to hopefully show you that it is possible to do this already now. So on the capture side, and I'm very glad Mohamed went into detail on the technical aspect because I'm not able to. But there are some challenges that were faced by the project when it comes to especially refurbishing or adding carbon capture to an existing biogas plant, which is space, right? So integrating technology within limited space depending on where the biogas plant is. Choosing the technology, because that locks your plant in for quite a while, so it's very important to choose appropriate technology. Integrating the infrastructure in the existing biomethane biogas plant without disrupting the ongoing operations. And a key aspect is also the feedstock changes. So you need a certain quality of CO2 at the end of your process in order for it to be accepted by the storage site. And depending on what goes in at the beginning of your process, this might require sort of changes into the capture parameters. So these changes happen, and it's important to continuously monitor them. The good news is that there are more and more solutions which are standardized when it comes to carbon capture technology. So we see container-sized, so quite compact carbon capture units that are liquefaction units that are being developed, and this will facilitate quite a lot the process. The other good news specifically for a biogas plant is that the CO2 that comes out of the biomethane purification process is almost pure. So the energy needed for the final step for the liquefaction is quite limited. And finally, a very important aspect for these BECCS projects is the reputational risk. We've seen quite a lot of very large projects with questionably sustainable biomass going into there as feedstock, whereas biogas plants generally use local waste and have quite a stable, sustainable biomass feedstock. And so Airfix's role on carbon capture is relatively limited. We focus more on the rest of the value chain, but we do work closely with carbon capture providers and technology providers. We work with Karim quite a bit in carbon impact, so to help biomethane plants to choose their technology providers. And one key aspect, again, the biomass feedstock. So especially for larger plants, we have a team that does biomass eligibility analysis. So looking at the different certifications at the EU level and at the national level to really see whether or not the project is eligible for carbon removal. And the sustainability of the biomass is absolutely crucial for this to be the case. So moving to transport, and I apologize, the slide is very packed, but there are quite a lot of challenges and opportunities in this space. As I mentioned, it's a multimodal transport system that you need. So this is quite complex for an emitter to manage. The infrastructure needs are not entirely there yet. So ideally in the future, you have more intermediate storage options at different hubs in order to enable a smoother transport system. The risk sharing, so you know, if we want to transport all the way across Germany and there's a strike on the German railway, who takes the risk? This is none of the logistics companies will take that risk. So the risk sharing between the different entities is a key aspect as well. The transport can end up being between a third and almost half of the cost of the overall cost of the value chain. So in that sense, it's also a very important aspect to optimize. And it is dependent on the future prices of energy. So no transport company now will give a fixed price for the next 15 years because they have no idea what the energy prices will be in 5 to 10 years. So this uncertainty is also one to manage. The regulatory complexity, so in certain countries, specifically in Switzerland, for example, CO2 is still considered a waste product. And then the moment it passes some borders, then it's not considered a waste product, but a hazardous material. So having to deal with this different regulation in the different countries that are passed is also a challenge that we try to navigate. And finally, Switzerland, not the best country ideally to start these projects because it's lower volumes far from storage sites. However, so this paints quite a bleak picture, but there are quite a number of opportunities. So aggregation of volumes is one of the key levers to really reduce the overall costs. If we can pool 5, 10, 20 biogas plants, potentially also waste-to-energy plants in a same region and create a hub around that, then we get access to different transport modalities that will be more efficient and from a cost perspective and also from a CO2 emission perspective. We also really try to push that small and medium-sized emitters be included in the CO2 infrastructure network that is currently being thought of for Europe. Because now we look a lot at where are the plants that have 500,000, 1 million tons of CO2, but we kind of forget all the small, medium-sized emitters that also have a potential to contribute to the climate objectives of Europe. The good part, so with the negative aspects of smaller scale, the good thing is that it does not need new infrastructure. All it needs is an isotainer, well, several isotainers, and this can then be put on existing trucks, on existing rail, and it doesn't need new ships, it doesn't need new terminals, so in that sense it actually is quite a bit swifter than the larger projects. Finally, the flexibility aspect. So as it does not need new infrastructure, projects are more, the transport assets that we need for this project are more easily rerouted if, for example, in five years there is a new storage site in France or in Italy, which is much closer to these Swiss emitters. There is an opportunity to divert the CO2 back to a different site. And so this is really the focus of what we do at Airfix. So we really try to act as an aggregator of volume, so working with several biogas, biomass plants, and grouping them into portfolios, into clusters, so that we can negotiate better conditions for the storage sites. We can also gain access to better transport modalities and basically lower the cost overall for the different projects that we work with. We also work with a network of logistics partners, so to basically help them help emitters secure the right logistics partner for transporting the CO2 to the storage site. And finally, we stay very much aware of all the regulatory evolutions and try to influence them as well in Switzerland, and basically support with the permitting and having the right, let's say, having the right permits to transport CO2 across borders. So this is just a bit of a summary on what we think the European CO2 network, transport network has to be in the future. It has to be inclusive to include small and medium-sized emitters. It has to be flexible so that we avoid stranded assets in the future and have a system that is modular. It has to be efficient to minimize the impact of the CO2 impact and minimize the cost. Every ton of CO2 that we emit on the way to the storage site is CO2 that we cannot consider as removed from the atmosphere, so it's a loss for the project. So it is in our own benefit to make it efficient. And finally, resilient, so that it can sustain the volume of CO2 that we expect to come in the coming years. So a quick on CO2 storage. very quick note, we focus so far mainly on CCS, well, BECCS. We also believe that BECCS is absolutely crucial, and in certain cases, if there's a utilization option close by, it makes a lot of sense to go in this direction as well. But we believe that both have to advance in parallel, so I'll focus here on the CO2 storage part. So early movers, so that want to start injecting CO2 in 2025, 2026, they have a limited number of storage sites that are already ready to receive CO2. So it's important to be in those discussions, and we've been in them for 2 years, and only now they are ready to move into commercial contracts. There's a limited appetite as well for storage providers, because the storage providers, they talk to emitters that have 500,000 tons of CO2 per year. And if Regionalwerke Baden arrives and says like, hey, I have 5,000 tons of CO2, can we enter in very long negotiations about this? They are less keen on spending the time. So here, this is also a challenge for smaller emitters. Most of the storage sites, they operate under take-or-pay contracts, which means the moment the contract is signed, whether the CO2 is delivered or not, the emitter has to pay for the storage capacity. They also require quite stringent guarantee requirements on the contracts. So these are quite large contracts, generally signed for 10-year lifetime, several million euros per contract. And so they typically require financial guarantees. So for smaller institutions, this can be sometimes hard to obtain. And finally, cost transparency. So there are few players on the market that are already at the stage where they can offer commercial deals. And so there is no typical market price that we can benchmark on. Again, whether the opportunities there, so aggregation, for the same reason as for transport, the more volume we have, the more also power of negotiation there is with the storage sites. And also the more interest the storage sites take in their projects. Reliability, so one advantage of biogas project is that the implementation of the carbon capture is quite a bit simpler than for other projects. So they see it as less risky that the project does not reach a final investment decision and does not reach the point where it starts capturing the CO2. So in that sense, it's a more reliable project, even if smaller in volume. The small volume is actually an advantage as well, because it's easier to accommodate within an existing storage site. It will not be sufficient for a storage site to take a FID based on smaller volumes. They will need the very large ones, but they are able to accommodate small volumes within their current activities. And finally, you do see that the financial and insurance industries are starting to take interest in the CDR space, in the CCS space. So we expect that they will become more and more comfortable with providing financial guarantees or insurance around these projects. And so similar to transport, Airfix acts as an aggregator to negotiate contracts with the storage providers. And we try to secure storage within the different entities that are providing them in the next 2 years, in order to then offer them to emitters, to a portfolio of emitters. And we're also working on guarantee instruments that we can take that guarantee requirement off the shoulders of the emitters. And the final part of the value chain that is often a bit forgotten is the monetization and the MRV, so monitoring, reporting, and verification. So the challenges there are, how do you choose the right carbon standard? There are quite a lot of them with a range of different, quite heterogeneous robustness when it comes to what they require to measure, how often they verify, what is the system, basically also where does the scope of the project stop, so where does the BECCS project start, where does the biogas project end, etc. So navigating these carbon standards can be a challenge. it is still quite complex to register a carbon project. It's something that it's still quite a niche project, and it's new for these type of emitters to have to deal with these projects. Data collection for the MRV process is also a very important point. And finally, one of the challenges is who will in the end buy the carbon removal certificate. So most of the biogas projects or even BECCS projects, we're talking between 250, 300 euros per ton to up to 450, 500 euros per ton. And we need to find buyers that are willing to take up those volumes, because the projects need them to take final investment decisions. So what are the sort of opportunities when it comes to monetization and MRV? We do see a lot of great initiatives now on ensuring the integrity of the certificates. The voluntary market has gone a bit through a turmoil in the last 1 or 2 years, and it's absolutely crucial for BECCS to work with the highest integrity when it comes to where the biomass comes from and how we measure the actual impact of those projects. There are also dedicated methodologies that are being developed through the CCS Plus initiative, Vera, Puro. There are quite a number of them that are starting to be available now for projects. There are also a number of companies developing digital MRV systems, which should make the whole process quite a bit swifter. And there is a growing market demand for CDR. It's still small relative to what we need in order for the CDR market to scale and for the net zero strategies that most of the companies have. But the signal goes in the right direction, the curve is going in the right direction, and we believe this is going to scale and be available for the BECCS project. And there are a number of marketplaces and buyers clubs. So our parent company, South Pole, started NextGen last year, which is a pool of buyers that have committed to buy 1 million tons, 1 million certificates from CDR, tech-based CDR, over the next 2 to 3 years. And so what does Airfix do in this case? So we help with the selection of carbon standards. We lead or support the development and registration of the projects. We help to develop also the MRV concept to make sure they align with the carbon standards. And we tap into our portfolio of clients and the portfolio of clients that our mother company works with, in order to find buyers for the CDRs of the project. That's it for me. Thanks so much for your attention, and yeah, looking forward to your questions.
Okay. Thanks, Aymeric, for this comprehensive overview. And well, yeah, there's a question in the room, so please.
Yes. So with the financing that was secured from the ClimateSend Foundation, this financing covers the cost is around 450 francs, so equivalent to more or less 450 euros per ton, and this covers the capture, transport, storage, MRV, so the cost of the whole value chain.
Okay, thanks a lot. So to wrap up this session, merci Aymeric. To wrap up this session, we'll have Patrick, an expert in geology from EOSYS, focusing on the last step of the process, which is storage of CO2. Patrick?
Hello? Yes. Bonjour à tous. Je vais parler en français. Peut-être que je parlerai un petit peu en anglais aussi, parce que les slides sont en anglais. Donc voilà, commençons en français. Donc EOSYS est une société que j'ai créée il y a une trentaine d'années et qui se spécialise dans l'exploration du sous-sol. On intervient donc aussi bien, enfin, on est intervenu parce qu'on a un petit peu calmé nos activités de ce côté-là, aussi bien dans le secteur minier, pétrolier, que dans le domaine du stockage. On est intervenu notamment sur des campagnes sismiques pour le compte de Total ou Engie, qui s'appelait à l'époque GDF, où on s'intéressait à la fois à la recherche de pièges pour faire des stockages souterrains et à l'intégrité des couvertures. On a également fait de la simulation pour voir un petit peu comment pouvaient se comporter les couvertures en cas de fuite. Et les bulles également de gaz dans les stockages. J'ai dû commencer mon premier projet d'injection de CO2 il y a 40 ans. Ça a été en tout début de carrière. Ça faisait déjà 10 ans que ça se pratiquait couramment au Texas. Et à l'époque, personne ne se posait trop de questions par rapport à injecter du CO2 dans le sous-sol. Voilà. Donc le BECCS, très rapidement, s'intéresse qui? S'intéresse l'agriculture, les bioraffineries, la production de biohydrogène, production d'énergie et production également de déchets, traitement de déchets. Alors pourquoi le BECCS? Alors je vais résumer très vite les travaux du GIEC en une slide. Aujourd'hui, on émet dans l'atmosphère 10 gigatonnes de carbone par an. Et c'est du carbone géologique, en fait, qu'on injecte dans la biosphère. Et d'un autre côté, on a des processus naturels de stockage géologique de ce carbone qui sont de 0,5 gigatonnes par année. Donc vous voyez, c'est très lent. Et qui plus est, ces processus sont quasiment compensés par les émissions volcaniques. Donc autant dire qu'il n'y a pratiquement pas de phénomène inverse à l'émission de carbone fossile dans l'atmosphère. Tout ce carbone rentre dans la biosphère. Alors la biosphère est quand même limitée. On a émis depuis le début de l'ère du charbon 436 gigatonnes dans la biosphère. La biomasse est de 560 gigatonnes et le carbone atmosphérique de 750. Donc on sent bien qu'on a quand même bien bousculé le système et on ne peut pas aujourd'hui s'affranchir d'un processus par lequel on réinjecterait ce carbone géologiquement dans la géosphère. Voilà. Alors quel est le meilleur moyen? J'ai un petit peu mis entre parenthèses les activités de ma société il y a 3 ans pour réfléchir sur le fond à ce qu'on pourrait faire. Conclusion, la seule façon raisonnable d'espérer faire quelque chose, c'est par la photosynthèse. La photosynthèse, ça ne se limite pas après à couper des arbres et à les refaire brûler dans l'atmosphère en faisant des bioénergies. Elle stocke également du carbone dans le sol. Par les racines, on va altérer la couche rocheuse. On va mettre du carbone dans les aquifères et très lentement, on va, en favorisant la photosynthèse, favoriser le stockage géologique du carbone. Même si ce n'est pas des ordres de grandeur énormes, ça va dans le bon sens. Alors les modes de séquestration géologique du carbone, voilà 4 exemples. Donc c'est ce qu'on va parler aujourd'hui. C'est injecter du CO2 capturé dans la subsurface, de faire réagir chimiquement le CO2 avec les roches encaissantes. Il y a également d'autres méthodes dont on ne va pas parler, qui concernent à utiliser les zones de subsidence pour y enfouir de la matière organique. Et également avec la pyrolyse du méthane, où on se retrouve avec 10 fois plus de carbone que d'hydrogène, utiliser ce carbone pour remblayer d'anciennes mines ou d'anciennes carrières. Alors, BECCS, qu'est-ce qu'il y a derrière le S? S, en fait, c'est 2 choses. C'est à la fois séquestration et stockage. La différence entre les deux, c'est que le stockage, on peut revenir dessus, c'est-à-dire on peut stocker du carbone de façon intermittente, du CO2 de façon intermittente et revenir le réutiliser quelques années plus tard. C'est possible, alors que la séquestration, il existe aussi donc des méthodes, il se passe des processus qui font que ce carbone, une fois qu'il a été injecté dans le sous-sol, ne reviendra pas à la surface. Ça s'appelle le piégeage résiduel. Je passe assez vite, on pourra revenir si vous voulez. Alors, quel est le principe du stockage? Vous voyez la grosse bulle en bas, ça représente un volume de gaz carbonique qui sortirait d'un centre de méthanation. On va le comprimer, on va augmenter la température et on va en faire du CO2 supercritique. À partir de 800 mètres de profondeur, on a la température et la pression qu'il faut pour que ce gaz carbonique a une densité de 0,5 qui est proche, enfin la moitié de celle de l'eau, ce qui est beaucoup, ce qui facilite son comportement comme un fluide et non comme un gaz. Alors, une fois qu'on l'aura injecté, on va donc avoir un fluide plus léger que l'eau, très peu visqueux, il sera 10 fois moins visqueux que l'eau. Il va se déplacer très facilement vers les points hauts de la zone où on l'aura injecté. Et il laissera derrière lui des bulles résiduelles qui peuvent être, enfin ça peut être une fraction relativement importante. Et on peut concevoir des stockages justement pour qu'il y ait une fraction résiduelle importante qui soit laissée derrière le train de CO2. Alors d'autres phénomènes vont se passer. Il va y avoir des systèmes de convection parce que des courants de densité qui vont mélanger ce gaz carbonique, qui vont augmenter la phase qui est piégée. Et cette phase piégée va ensuite interagir avec les roches pour se minéraliser et se dissoudre dans les eaux encaissantes. Alors, et pas seulement ça, si vous voulez, une fois qu'elle est piégée, ce qu'on ne sait pas trop encore pour l'instant, c'est qu'est-ce qui va se passer au niveau biologique. Il y a, si vous voulez, dans la biosphère, c'est environ 560 gigatonnes de carbone. On estime aujourd'hui 70 gigatonnes de carbone, l'activité, enfin ce qui correspond à l'activité microbienne sous nos pieds. Hein, sous 5 ou 6 km de couche terrestre, on a des microbes qui sont actifs et on l'a constaté sur certains stockages, le CO2 se transforme en matière organique. Ça peut faire des biofilms qui empêchent l'injection, ça peut aussi faire du méthane qui, si on gère les choses intelligemment, pourrait être éventuellement récupéré 10 ans ou un siècle plus tard. Alors, ce qu'il faut aussi dire, je reviens en arrière, oui, c'est qu'on parle beaucoup d'hydrogène naturel en ce moment. Ce carbone qu'on met dans le sous-sol, s'il y a de l'hydrogène naturel qui passe dans les parages, ils seront très contents pour en faire, pour le consommer. Alors l'autre méthode pour stocker géologiquement le carbone, c'est par l'injection de CO2 dans des basaltes. Je passe rapidement là-dessus, hein, c'est ce qu'on utilise en Islande. Et ça permet en fait de faire le piégeage minéral de manière beaucoup plus rapide que dans les stockages, ce dont on parlait tout à l'heure, enfin dans les stockages en phase gazeuse ou liquide. Donc voilà un petit peu pour les processus de séquestration géologique. Vous voyez, c'est un phénomène qui est beaucoup plus complet que ce qu'on entend et qui mérite vraiment d'être aujourd'hui testé. On manque de mesures, on manque d'expérience pour savoir exactement ce qui va se passer réellement d'ici un siècle ou deux dans ces stockages. Alors les opérations BECCS en Europe, bon, soyons clairs, il n'y en a pas. Par contre, du CCS, il y en a. On prévoit d'en faire. Donc aujourd'hui, c'est l'industrie lourde qui drive le processus, et les sociétés pétrolières en particulier. Donc aujourd'hui, il y a quelques pays européens qui ont déjà leur roadmap pour le CCS, ce qui est marqué à gauche ici. Donc France, Angleterre, qui n'est pas plus de l'Europe, Norvège, qui n'est pas de l'Europe, Danemark, hein, sont les deux pays qui ont leur roadmap. L'Allemagne et la Suède sont en train de leur faire. Donc là, vous voyez tout un ensemble de projets qui sont en train de se préparer. Donc il y a eu un énorme accroissement, hein, plus 61% en 2023 par rapport à 2022, qui était déjà une bonne année dans les projets CCS. Il y a tout un ensemble de dispositions européennes qui sont en train d'être prises, hein, pour faciliter tout ça. La mer du Nord est et continue, alors je sais pas, d'être là, pardon. On va y arriver. Oui, la mer du Nord, vous voyez, reste la zone principale de stockage en projet. On commence à en voir quelques-uns qui apparaissent dans le bassin méditerranéen et en Europe de l'Est. Et voilà un petit peu la croissance. Comment je fais pour pointer? C'est celui-là? Ouais. Voilà. On voit en fait la croissance qu'on doit attendre à partir de 2024. Donc aujourd'hui, on parle littéralement de zéro. Zéro, c'est-à-dire, qu'est-ce qu'il y a dans ce zéro? Ben, il y a les champs dont on parle beaucoup, les champs de Sleipner et Snøhvit en Norvège. C'est beaucoup hein, dans la communauté du CCS, puisque c'est des expériences qui datent maintenant depuis 1996 pour la première, et qui sont les premières au monde de stockage de CO2 dans des aquifères. Mais c'est rien à l'échelle de ce qu'on doit faire et ce qu'on s'attend à faire en 2035. Vous voyez ? Donc on a le Danemark qui vient juste de commencer un projet, la Croatie où il y a des projets mais on n'a pas de données, et l'Islande avec stockage dans les basaltes, où là c'est vraiment epsilonesque, on a 0,004 millions de tonnes de CO2 par an. Donc voici ce qu'aujourd'hui on a programmé dans les projets que je vous montrais un petit peu plus haut. Alors voilà un petit peu les zones, enfin une cartographie des zones dans lesquelles on pourrait faire du stockage, qui est un petit peu restrictive à mon avis, hein, on reviendra dessus. Alors si on se limite à la France, en France aujourd'hui on émet 408 millions de tonnes d'équivalent CO2 en 2022. On envisage en 2026 de lancer des projets de 4 à 8 millions de tonnes par an, c'est-à-dire déjà 2 à 4 fois plus de ce qui se fait dans toute l'Europe. Et on a pour objectif de passer de 15 à 30 millions de tonnes à l'horizon 2050, en espérant passer nos émissions de 422 millions à 80 millions de tonnes en 30 ans. Alors on a tout un ensemble de zones où on peut faire du stockage en France, mais on travaille aussi surtout beaucoup sur l'exportation vers la Norvège. Alors si je me mets maintenant dans le monde du bio-CCS, voilà toutes les usines de biogaz. Je parle que du biogaz là, hein, pas d'autres modes de production biologique. Vous voyez, il y en a beaucoup. Et vous voyez ici les bassins sédimentaires. Hein. Voilà la carte réellement des bassins sédimentaires dans lesquels on peut faire de la séquestration de CO2 en Europe. Et en rouge, ce sont les champs pétroliers. Donc en 2022, on a produit 4,2 milliards de mètres cubes à partir de 1323 unités, ce qui fait à peu près 5 à 8 millions de tonnes qui ont été coproduits de CO2, c'est-à-dire 2 à 3 000 tonnes de CO2 par année et par usine. On pourrait tout à fait mettre en place des pilotes dans toutes ces zones-là pour stocker ces petites quantités de CO2, et les budgets seraient de l'ordre de 1 million d'euros. On est dans des choses qui sont, je veux dire, de l'expérience qui est relativement peu chère par rapport aux énormes budgets dont on entend parler actuellement autour du CCS. Voilà donc un petit peu le panorama. Alors si on parle des coûts maintenant, je vous recommande la Clean Air Task Force, qui n'est pas européenne, c'est une organisation américaine, mais qui a des bases de données qu'on peut consulter sur les coûts. Donc je ne suis pas trop rentré dans les détails, mais vous voyez un petit peu pour l'Allemagne, tous les points qu'ils ont regardés et les coûts de CCS qu'on peut avoir entre 90 et 200 euros la tonne, déchets, métallurgie, etc. Donc on a aujourd'hui pas mal de données. Alors ces coûts, ils dépendent à la fois donc, de la source, du type de gisement dans lequel on va pouvoir stocker le CO2, de la distance à ce gisement et du type de transport. Alors les États-Unis sont un petit peu plus avancés que nous par rapport au bio-CCS, puisqu'ils ont tout un ensemble d'usines de production d'éthanol où on peut capturer le CO2 à un coût très marginal, c'est de l'ordre de 30 $ la tonne, ce qu'ils estiment. Et ils ont regardé un petit peu les coûts de transport et les coûts de stockage. Donc vous voyez, il y a un spectre très large. C'est vraiment du cas particulier, on ne peut pas trop généraliser les choses. Il faut vraiment étudier les choses localement, à façon. Et j'insiste sur le fait que les stockages aujourd'hui sont très mal connus. On a une cartographie, par exemple, en France, qui est au 50 millième du sous-sol. Si vous voulez chercher un stockage à côté de votre usine à biogaz, dans un rayon de 20 km, il vous faudra une cartographie au 5 millième. Et vous en trouverez. Vous en trouverez par rapport aux quantités minimes, finalement, que vous pourriez valoriser. Voilà, donc, conclusion, il faut arrêter de procrastiner, il faut y aller, il faut tester, il faut engager à la fois les acteurs locaux, il faut que ce soit eux les moteurs, hein. Si ça ne vient pas des acteurs locaux parce qu'ils y verront un intérêt, il y a quand même des jobs qui sont derrière ça. Il y a quand même la possibilité de gérer soi-même son propre carbone, d'être négatif en carbone, c'est quand même assez satisfaisant. S'ils sont aidés par les pouvoirs publics et par des investisseurs, il y a matière à lancer donc, une exploration géologique intense dans beaucoup d'endroits, avec de la sismique 3D, avec des forages d'exploration, ceux-ci pouvant faire l'objet d'ailleurs, avoir des retombées en ce qui concerne la géothermie, l'hydrogène natif et l'exploitation de métaux dissous comme le lithium. Voilà, il faut y aller. Conclusion.
Okay. Merci Patrick.
Experimenting, il vaut mieux expérimenter et essayer de le stocker tout de suite plutôt que de continuer à le balancer dans l'atmosphère comme dans une poubelle. Voilà.
Merci Patrick. So we're reaching the end of our panel. So are there any questions for any of the panelists before we wrap up? Comments, questions? Yes?
Merci. Thibaut Neu, CCUS Technologies. J'ai une question pour le dernier intervenant par rapport aux risques associés à la capture du CO2, surtout si on fait des petites installations. Y a-t-il un risque de relarguer du CO2 et si c'est le cas, qu'en est-il pour les populations environnantes?
Alors, moi, je parlerai moi pour la séquestration ou le stockage, hein. C'est ce que j'expliquais. Imaginons qu'il y ait des fuites. Imaginons hein, que la couverture, par exemple, présente des fuites. Bon, vous imaginez un point d'émission avec un panache sur 800 mètres qui va se développer sur une très large zone. Et il est très probable que vous allez rencontrer d'autres formations, et d'ailleurs la conception des stockages se fait dans ce sens-là, vous rencontrerez d'autres formations imperméables en chemin qui, à mon avis, bloqueront le panache avant qu'il arrive un peu plus haut. Et si ce n'était pas le cas, vous avez une activité bactérienne qui va devenir extrêmement forte au fur et à mesure que ce CO2 va s'approcher du sol. Donc on ne va pas rentrer dans un cas comme celui d'un pipe qui a explosé là, il y a quelques années en Louisiane, où là on avait du CO2 supercritique en surface qui s'est répandu et qui a causé un véritable accident. Dans le cas d'un stockage géologique, on n'est absolument pas dans ce cas de figure-là. On a du CO2 à température ambiante qui, dans le pire des cas, arrivera en surface et très probablement sera intercepté par des microbes au passage et fera que vous aurez des cultures qui croîtront mieux que ce que sans savoir pourquoi.
Ok. Merci. Encore de dernières questions avant de conclure. Okay, so thank you very much for your patience for this panel. I hope you have a better view now on BECCS, and well, please enjoy the rest of your event, and feel free to come talk to any of us in case you're interested to go further. Thank you very much. Merci.